We're back to notch filter tuning on this little platform. We'll go ahead and get started on that. There's nothing actually to do here on the platform itself, so we'll look over at the computer. Here's where we're at. ardupilot.org, documentation, copter. We're actually in first flight in tuning on this. Tuning right here and configuring notch filtering. So we've been here before, but myself, this is my second time trying notch filter tuning. When I rebuilt the flame wheel last year and tried to fly it and it wouldn't fly for me and I gave up. Turns out to be because of this, more than likely, because I didn't come look at the documentation when I rebuilt the flame wheel. I just went into Mission Planner and worked through the things that were in there, as I did when I built quads 8 or 9 years ago, and it didn't work out for me. So when I built the 7-inch from scratch, I started going through this documentation instead of Mission Planner, and that's when I ran across these notch filters that I'd never seen before. It was added between the time took my sabbatical around 2017, 2018. My last copter build before that was probably 2015. I hadn't built a copter in about 8 years. I built up several back then, flew them for hundreds of hours, and just never saw notch filters before. So if we look down through this, it starts talking about it. I'm not going to read this again. I read it the first time we went through here almost verbatim. We're down to this part, determining notch filter center frequency. That's what we're after right now. We want to find the frequency we want to filter. Before actually setting up a dynamic notch filter, the frequencies that are desired to be rejected must first be determined. This is crucial if throttle-based dynamic notch setup is used. I think it's pretty crucial no matter what is used, but we'll continue with their text. We'll be doing one of these too as part of this. While the other methods do not require this knowledge, it is still worthwhile as a comparison point for post-filter activation analysis of the filter's effectiveness. Now, I did not see that before. Boy, I'm learning. It is crucial for throttle-based, while the other methods do not require this knowledge. Wow. Why isn't it required if we use RPM based? Why is it not required if we use ESC telemetry based? See, this one just got me. Okay. See the measuring vibration with IMU batch sampler page for this step. Once the noise frequency is determined, the notch filters can be set up. Before I go over here, see, this key to the dynamic notch filtering operation is control of its center frequency. There are 5 methods that can be used for doing this. Up there it kind of alluded to that it's only used for mode 1, throttle based. Oh well. Boy. I used telemetry based on the 7-inch, I think. Oh well. So we'll go over here to measuring vibration with the IMU batch sampler, because we are going to talk about throttle base, because there is a viewer that needs that. I needed it back before I got really feeling bad and quit doing videos there for a while. I still don't feel 100%. I've still got one medical procedure to go through to see if we can find out exactly what's going on. But the pain has lessened. And the pain was what stopped me from doing videos. I was just so sidetracked with that. I thought I was making a lot of mistakes in the videos. More than my normal for not doing scripts. Measuring vibration with the IMU batch sampler. The IMU batch sampler can be used to record high frequency data from the IMU sensors to the data flash log and autopilot. On the autopilot, the data can be analyzed post-flight to diagnose vibration issues using graphs created from the fast Fourier translations of the data. It says fast Fourier transforms. I always knew this as fast Fourier translations, used in all sorts of different types of computer programs. The fast Fourier transforms data from the time domain into the frequency domain. Put another way, accelerometer data recorded over time, i.e. a flight, can be converted into a graph showing the frequency of the vibration. A frequent feature of these graphs is a spike at the propeller's blade passage frequency. The frequency at which the blade crosses over the arms, which causes an acceleration in the aircraft body. Seems like as the blade passes over the arms, it would be a downward acceleration in the body caused by the force of the blades on the arm. Doesn't say that here, but the fast Fourier translations has the following limitations. The FFT cannot show you frequencies above half your sensor's sampling rate. Well, wouldn't think it would be able to show you frequencies above any of its sampling rate. The smallest frequency that can be shown is half your sample size divided by your sample rate. Oh man, see, this is why people just really don't like this, me included, because until I built the 7-inch from scratch this year, I'd never seen this. Samples are typically taken at the same rate as gyro updates provided to the autopilot. For example, if you're using INS fast sample on an MPU 9250 sensor, then samples will be taken at 8 kilohertz, but averaged and downsampled to 1 kilohertz. If you are not using an autopilot with fast sampling capabilities, then the sample rate is 1 kilohertz. The 1 kilohertz back-end rate is the rate at which gyro filtering takes place, i.e. low pass and notch filters, and on smaller copters 1 kilohertz is not high enough to avoid aliasing from noise at higher frequencies. For example, a 3-inch copter might have a full throttle motor frequency of 600 hertz. Since filters can only apply at half the sample frequencies, it is not possible to filter 600 hertz noise when sampling at 1 kilohertz, and the noise will be aliased down to lower frequencies. Maybe I shouldn't start this so early in the morning, because all of that's going right over my head. I think somebody just likes to hear themselves talk. The back-end rate has been made configurable for IMUs that support fast sampling. so that higher rates can be supported. The back-end rate that can be configured by setting INS gyro rate. The default 0 gives the same behavior as previous firmware versions. A rate of n gives a back-end rate of 2 raised to n kilohertz. So for instance, a value 1 gives a back-end rate of 2 kilohertz. Boy. This raises the rate at which all gyro filters are run and can be computationally expensive depending on the number of notches configured. Values above 0 are only recommended on F7 or H7 platforms, and values above 1 should only be used with careful tuning. This is automatically done for those platforms. This allows capturing of frequencies at 1 kilohertz and below on these autopilots. Well, I've got an F7 flight controller, I do believe. It's an 8743. Pre-flight setup. INS log bat option equals 4 to do pre and post filtering 1K sampling. Set INS log bat mask to 1 to collect data from the first IMU. INS log bat LGIN is the gap between batch samples and normally does not need to be changed. It can be lowered to increase accuracy of the resulting fast Fourier translations, but may be ineffective depending on your system's logging speed. Log bit mask IMU raw bit must not be checked. The default log bit mask value is fine. If it is checked, the results can be confusing, as you will get no samples if using post filter or regular logging. You will, however, get samples if using sensor rate logging and your SD card is able to cope. Okay, let's look at some of this. Go back up here. INS fast _score sample. I want to look at that in this platform just for kicks and grins. See, and I haven't been exposed to this very much at all. By the way, this platform has been moved up to 4.4.0 beta 2. Almost all of mine have. Go over here and look at parameters. Go back to what we're looking for. INS _ fast. INS _ FAST _ sample. Wow. That one's turned on. I'm not sure that's what it said. It says the default is with it on. Mask of IMUs to enable fast sampling on if available. So if we click here, you see a 1 is the first one, a 2 would be the second one, 3 would be the first and second one, 4 would be the third one only, 5 would be the first and third one, 6 would be the second and third one, and 7 would be all three. Okay, I understand binary numbers, but if you are not using output fastness, sampling rate is 1K. Well, this value is just which IMUs are going to be used. I don't see that this paragraph works for me. It's just getting more confusing. We'll go INS gyro rate. We'll leave this one at its default. What is this? INS underscore GYRO. INS gyro rate is 1. That's the default. That is 1 kilohertz. That is 2 kilohertz. Okay. Documentation, and what I'm seeing is not working out for me. It's just becoming more confusing. INS gyro rate, the default 0. No, it's no longer 0. The default is now 1. God. Default is 1. The default is not 0 anymore, 1 kilohertz. It's now 1, which is 2 kilohertz. Maybe I should start throwing this documentation over my shoulder. Gives the same behavior as previous firmware versions. A rate n gives the back-end rate, which gives... So for instance, a value of 1 gives the back-end rate of 2 kilohertz. We do see this right there in the actual parameters on the platform and the defaults for Ardocopter right now. Hasn't told me to change it here. Just trying to clear up some of this stuff, and instead of clearing it up, it's just making it more and more muddy for me. Dang. So pre-flight setup for this, INS log bat options. INS log underscore bat. INS log underscore BAT. And what were we talking about there completely? OPT options. OPT, this bottom one. Options for batch sampler. It is at the default of 0. Equals 4 to do pre and post. So we come in here. Sensor rate logging. Sample pre and post filter. So when we check this, it will be a 4. This has a weight of 1. This has a weight of 2. This has a weight of 4. They're added together, so this will make it a 4. There we are. It is a 4 now. Write parameters to the platform. It is a 4 now. Set INS log bat masked equal 1 to collect data from the first IMU. Mask. IMU 1. There we are. And write that to the platform. INS log bat. Looks like login, LGN, whatever that is the gap between batch samples and normally does not need to be changed. However, it can be lowered to increase accuracy of the resulting fast Fourier translations, but may be ineffective depending on the system's logging speed. I think this FC is pretty quick. Well, let's look at that. Log bat 20. Oh God. That's its default. Reason I said, oh God, that's the gap. Can be lowered. I'm going to leave it at the 20 for now. Log bit masks IMU raw bit must not be checked. The default log bit mask value is fine. Well, it's still the same as you think it is, people. So log bit masks. I'm going to scrape through this right here for kicks and grants. Oops, can't do it that way. Can't do it that way. Try that. Yeah. And there's a space in front of that. Oh boy. Okay. I'm going to have to go back and read that because evidently there's a lot in there. Log bit masked IMU raw bit must not be checked. The default log bit mask value is fine. Not if it has the IMU raw bit checked. If it is checked, the results can be confusing, as you will get no samples if using post filter or regular logging. You will, however, get samples if using sensor rate logging and your SD card is able to cope. Boy, thanks guys. That just really made me feel so much better. Right. So we'll look at this. A value of 176,126 means all of these are there. And it's this fast IMU is what it was talking about. Was that it? IMU raw bit must not be checked. Okay, here's raw IMU. Fast altitude, medium, GPS, system performance, control tuning, navigation, IMU, compass, camera, motors. Okay, this raw IMU, which I guess is IMU raw, wish the documentation matched the nomenclature in the actual firmware, but I'm going to assume that IMU raw is raw IMU. Boy. So it is not checked. So I'm going to leave that as it is, which is the default. So there was no need to write that out. Flight and post-flight analysis. Perform a regular flight, not just a gentle hover of at least 1 minute, and download the data flash logs. So I guess I'm ready for that. I'm not mentally ready for that because all this stuff is just messing with me. I don't think the documentation matches the current firmware, in my humble opinion. Open Mission Planner, set up, press the FFT button, press IMU batch sample and select the .bin log file downloaded above. Open Mission Planner, under Setup Advance, press the FFT button. I'm just looking at this right now. That'd be Setup Advanced. Here's the FFT button. So I'll be going into here, it looks like. I didn't do this on the 7-inch, I don't think. That's why we're going to redo the 7-inch. Press IMU batch sample and select the .bin log file downloaded above. Okay, I don't actually have that right now, so we're going to have to fly it first. .bin log file, IMU batch sample. IMU batch sample. I would click here, and then I would go looking for my log file. Okay, I think I got that. So we'll be in this area when I come back from the flight to actually generate this data flash log. So I need to set this up on the 7-inch also, and there's some other things I need to do on the 7-inch, so we're going to look at that right now while we're here. Over here we're going to replace the little 5-inch right now. They use different USB cables, so I can slide that one aside, put this one in here, and set up its USB and turn that on. Okay, this is the little 7-inch. It's also on version 4.4.0 beta 2. I made this video a second ago, and when I pulled it into my program to make my full video, there was no sound on this video for some reason, so I'm redoing it right here, but we're going to see all these values I come to are already set up. INS log bat option to 4. INS underscore log. Bat option is set to 4, which is for pre and post sampling. The INS log bat mask is set to 1. Again, that's this one here. That's for the IMUs that we want to look at for developing the data. IMU 1 only. The INS log bat LGN, we're going to leave that at the default 20 that it comes set up in the firmware for. And the log bit masks says the default is fine. Just make sure that IMU raw or raw IMU LOG underscore BIT, that'll probably get it. Bit mask. Again, we go in here and this raw IMU is not checked. That's what we want. So we write those out to the platform. I did come in here, and because this platform had been auto-tuned and some missions and stuff flown on it, I had set up my return to home for low battery, radio, etc. I set all those to none and disabled because I don't want any return to home accidentally getting invoked here in the backyard when I do that little 1-minute flight and it flying off to Never Never Land. So I had to do that a little differently than the 5-inch. The 5-inch has never had those things set up, so it's not going to fly off to Never Never Land. It'll stay right here. My little brother called me a while ago. He's down at the fireworks shoot site, checking mortars, seeing how much the trees have grown over last year's height, etc., etc. He's got a few little problems down there, and he's got some questions about how I set up the show. So I'm going to have to help him with that the rest of today. I hope to fly these flights on these two platforms tonight near dark when the wind is completely calm. So I'll let you know if I do that. I'm going to go ahead and stop this video now. It's just getting too long. I'm going to break this whole series up into smaller chunks if I can. So we've got Monday and a portion of Tuesday up until dark to finalize the fireworks shoot and go ahead and shoot the fireworks for the Moose Lodge Tuesday night on the 4th. So I won't promise any videos for sure until at least Wednesday. I will try. Like I say, I really do want to fly the little test flights to develop the data tonight. I may fly it tomorrow, may fly it Tuesday. I don't know when I'll get those in, surely by Wednesday. It's just the little fireworks shoot has come upon us now. I always like to do the fireworks for the 4th of July for my shipmates and stuff at the Moose Lodge. So that's what's going on here. Thank you guys so much for everything.